have a Patreon.
Did you see it? In the middle of the screen, what looks like a ghostly apparition appears to scream, "I have a Patreon." Is this real evidence of the paranormal, or just an elaborate ad to get more patrons? You decide. Hello everybody, and welcome to an updated version of Demystifying Inventories. I don't even know if that's the title. Basically, the old method is still a completely valid method of creating an inventory system, but I've learned another way to do it, and it is my new preferred way. But for any inventory system, we first need to be able to pick up items. Let's jump into quickly making an interact system. I'm gonna go ahead and open up my content browser. I am searching for only static mesh. Let's undo that. We're gonna go into the first person. We're gonna go into input. I'm going to go to actions. I'm gonna right click. I am going to create under input, an input action. We're gonna do IA for input action underscore interact, and that's all we need. Control Shift S to save all, save all. We'll head back to input. And we're going to open up the IMC default, and we will open up the mappings. We will hit the plus button, and we will now select IA interact. If we expand the IA interact, we will now be able to set a key. I'm just going to set mine to F. You can set yours to whatever your preferred interact key is. And all that was simply saying I need a new button that I can call, and then we put it in the context of default, where F, or whatever you set, is now interact. And the good news, if we go ahead and hit Control Space and go to first person, blueprints, first person character, you can see the Unreal Engine default stuff. We are going to right click, and we're going to type in enhanced input, and you'll see that we have the access to the things we created. We do not want the value, we want the action event. So we want the IA interact, and now we have an event that occurs whenever we press our button. Let's go ahead and create a function. So on the left-hand side, we're gonna go ahead and hit plus. I'm gonna call this line trace underscore reach. Actually, we'll just make it line trace, that works. And then we're gonna require an input of a float, which is a distance. So whenever you require an input, basically what that means is whenever you call this function, it's going to require that we enter a certain amount. So that's what an input means. It means we need information for this to run. So that's what input means. All right, in the function, we are going to pull out of line trace, and we are going to do line trace by channel. Basically, this just means we're going to shoot a line forward with a starting and ending point, and we are going to try to hit things in the visibility channel. You can change this if you have additional channels. If you don't know what these are, leave it on visibility for now. However, in order to draw a line, we need a start point and we need an end point. This is a first-person game, or in my case, it's the first-person template. So I'm going to be using my first-person camera as the starting point, because that kind of acts as our face. So I'm going to pull out the first-person camera. I'm going to get world location, and that will act as the starting point. Because again, the camera is kind of like our face. So if we're going to interact with something, what are we looking at? So start at the face. Now we need an ending point. Well, to get an ending point, we have to have a direction and a distance. So to get a direction, we're going to pull out of the first person camera again, and this time we're going to get forward vector. The forward vector means what way are we facing? Okay, we have a direction, but now we need a distance. So let's go out of the forward vector, and we're going to multiply it, okay? Now you'll see that by default it wants to multiply it by another vector. Don't worry, if you take this distance and you plug it in, it will convert, and we can take that vector and multiply it by our float. And we're almost there. Remember that by default, it's going to assume the world origin. So we have a direction and a distance, but that's from the world origin. So we need to add the location of our starting point so it knows where to base this direction and distance on. So what we're going to do is out of our multiplication, we're going to add, and we are going to take our world location and add it, and thus we are now at the end point. Very fast recap. Starting point is our face. Then we see what way we're facing, we add a distance to it, and the location of our starting point to get the end point. So now we're going to shoot a line forward and see if we can hit anything. And then what we're going to do is we're going to pull out of that, we're going to type in return, and then we're going to pull out of out hit, drop it on the return node, take the return value, drop it on the return node, and now you can very quickly call line traces with your new function. So we're going to hit compile and save. This is why sometimes it's important to make functions instead of adding it to a random event. This is now a modular piece of code that you can use for any purpose you might need to line trace. So let's go ahead and close the line trace function. And now what we'll do is with our enhanced input interact, I'm going to pull out of started and do a line trace. So what's the difference between triggered and started? Triggered is going to go off every time the button fires. Have you ever held down a button in like Notepad and you know how like it'll go, okay, because it starts to rapid fire because you're holding the button down? Every time that happens will happen with triggered. With started, it's only going to do it once until the button is pressed again. In this case, that's what I prefer. With distance, we're going to go ahead and add a variable to our character called reach length, which will be a float. I'm going to hit compile and save so I can access the default value. And on the right hand side with reach length selected, you'll see that I can set a default value. I'm going to just set something like 500. That's kind of long, but this is just for testing purposes, and we'll hit compile and save. And then for the distance, I will then put in the reach length. The reason we do it like this is because now, anytime we need to have values set to our reach length, I can just change this value and it'll affect everything that is using reach length as a distance instead of just like unconnecting this and putting it like right here, because then I would have to come back and change that. Okay, so we can hit a button, we send a line out. Now we need to do the logic to send it a message if we hit something. So the first thing I'm going to do is I'm going to hold B and click, and you'll see that we get a branch when we do that. I'm going to plug in the execution pin, and then on the return value, I'm going to plug it in. So what this branch is going to do, what this return value does, is it lets us know if it hit anything. So on the node comment, I'm just going to say, did line trace hit anything? Like that. Oh, well, without the greater than sign. Okay, so did the line trace hit anything? If it did, we want to do stuff. If it didn't, we don't care. So with our out hit, if I pull it out, and hit break, you'll see what we're getting with the break hit, or the hit result is this is all the information the line got us when it went out. So what I need is the hit actor, but right now we don't know what's interactable and what isn't, so we have to stop the logic here until we can make a difference between an interactable object and a regular object. So I'm going to hit compile and save, and in order to see if something is interactable, we're going to create something called an interface. I'm going to hit control space, go to content. Now I'm going to create a new folder. I'm going to call it underscore. I always start my stuff with underscore because it puts it at the beginning of the folder structure. So underscore Brandon BPs or Brandon's blueprints, and open that up. I'm going to right click again. I'm going to create a new folder and call it interfaces because we will have multiple. Let's open up the interface folder. I'm going to right click. I'm going to go to blueprint interface. Now, the naming convention I use is BPI for blueprint interface underscore interaction. So basically, anything that's going to be interactable is going to have BPI interaction included with it. If you don't know what an interface is yet, don't worry, but they're extremely useful and you're going to learn all about them. For now, just know that it exists, and if something is interactable, it will include this. That's important because back in BP first person character, we're going to pull out of hit actor and we're going to type in does implement. So, and there you go. Does object implement interface. Then I'm going to hit this up arrow to save some space, pull this up, grab both, press Q so they're nice and straight. And you'll see that now we can select a class for the interface. Unreal comes with a whole bunch of default ones, but we're going to type in BPI, and you'll see there's ours, BPI interaction. So let's go over this again. We hit a button, we send a line forward, reach length, then we say, did it hit anything? And if it did, we check and see, well, does it implement our interaction interface? So I'm going to hit B and click, that's our branch. And I'm going to plug in this return value here, and again, right click. In this case, I'm going to say, does it implement BPI interaction? And there we go. So what do we want to do if it does implement the interaction? Well, right now we can't do anything. We need to go back to the interface we created. Let's hit Control space and open up the BPI interaction. For those that don't know what interfaces are, we're going to talk about it for just a moment, because it's very important to game development. This is how your blueprints are going to talk to each other. So anything that's interactable, we're going to create a set of functions that those items can have their own definition for. That might sound confusing, but let's do an actual example so you see what I mean. Right now, I'm going to click on New Function up here at the top right. If it doesn't automatically let you rename it, just press F2 and it should let you rename it. I'm going to erase that. And I always like to do a naming convention where I say immediately the thing, the main point, or the main object of the function, and then request. So, for example, we're going to do an interaction request. We're going to hit compile and save. Now, I like to do an output of a success. So I'm going to go ahead and add an output. You'll see it adds the return node. It does need to be a Boolean, and I'm going to put success here. We're going to hit compile and save. The reason this is important is because if two things are interacting with each other through the interface and it fails, and that's important information, like for example, you try to pick something up, then you don't have the inventory space, we can then have logic that says, oh, it failed, don't delete yourself and or whatever it was going to do. That's also why I call it a request instead of just a specific thing. Okay, so now we have the message and the thing that can be defined by something that's being interacted with. Let's use it. Let's go back to the first person character. So we hit something and it implemented the interface. So that means we know it has this function. We know because it's a part of the interface that it's implementing, okay? So what I'm gonna do is pull out of hit actor, and remember what I called it? I called it an interaction request. Now you'll see class, BPI interaction, interaction request. This is the important part, in parentheses, message, okay? That's important because we want to send this hit actor a message of interaction request. So hit true, or plug the true pin in, and then let's add some pins to the hit actor here so we can make it look a little more neat. And in this case, I don't care about the success. We will sometimes though. So for now, a very simple interaction system. We're gonna hit C, and I am going to type in interaction system. And I like to click on show bubble when zoomed up here at the top right, so that way when you zoom out, it's very quickly easy to identify what that code is. And we're gonna hit compile and save. Now, we see one side of the interaction system, one side of the interface. That is the side that's looking for something and then giving it a message. Let's go ahead and create a parent item, and I'll explain more about what I mean by parent item later on. But for now, let's go ahead and create a parent item that can receive this interaction request. I'm going to hit Control Space. I'm going to go back to Brandon's BPs. We're going to create a new folder, and we're just going to call this Actors. Within Actors, I'm going to create another folder, and I'm just going to call this Items, and I'm going to open up Items. So on the root folder, the highest folder within Items, we're going to create, which by the way, there's no other folders, but I'm just saying in typical folder structure, parents are in the root. Not always. Anyway, I'm going to right click and I'm going to make a blueprint class, okay? It's going to be an actor. And what we're going to do is we're going to type in BP underscore parent item. So the parent item is only going to include information that is necessary for all items. Let's go ahead and add some of those now. Let's open up BP parent item. We're not going to add anything to the components because there's a chance some items might not have a static mesh. Some items might have a skeletal mesh. Some items might be this, some items might be that. The point is, we don't know what every single item is going to have yet, except for a couple of base details. Like, for example, we know that our items are going to be interactable. So let's go up here to our class settings, go to the right-hand side, and you'll see that we can have interfaces. So let's go to the implemented interfaces, and we're going to add, remember, BPI, because we made BPI interaction, click. Now I'm going to hit compile and save. So now if the line trace was to hit a parent item or any of its children, it knows that it's interactable because it's implementing the interface. Now remember how in the interface we created this function? Well, because this blueprint now implements the interface, look on the left-hand side. Under interfaces, we have an interaction request. I can double click this and look, there it is. I can now define what it is this specific item does when we interact with it by simply undoing this execution pin, adding in logic, and then returning if it was successful or not. I hope you're starting to see why interfaces are going to be integral to our inventory system. For now though, I am not going to define anything. The reason I'm not going to define anything is because our parent item is not supposed to hold details outside of a template that other items are going to be created out of. So in our template, we do need the interaction class setting, or the interaction interface. What are some other things that typical items have? Well, let's go ahead and go to the variables and add some, like item name, for example. We can go ahead and open that up and just go to name. Let's add another one, thumbnail. So if we have it in our inventory, it can now have an image. So you're gonna notice, by the way, it's very difficult to figure out what it is you put here for an image. It's actually called a slate brush, and we're just gonna go ahead and click that. And honestly, we can add more later if we want, but I think this is a good starting point. Let's hit compile and save, and I'll briefly explain what parent to child relationships are so we can have a better understanding of what it is we're doing. Welcome to Paint, the thing that makes me more white than I already am. Okay, so at the top, we're gonna have our BPP for our blueprint, and then I'll spell it just so it's obvious, our blueprint parent. So it starts at the top, right? So let's say our blueprint parent has a Boolean inside of it. We'll make that red, like a Boolean. And I don't know, let's just make it enemy. Obviously, I'm just making stuff up right now. But you go ahead and you start making children of this item, okay? So we go ahead, let's make 3 different rows here, 3 different children. This ends up being the parent, so BP parent, and yes, a child can be a parent. So this ends up being the parent of NPCs. So this is an NPC. Well, because it is a child of the BP parent, it automatically, we know, is going to include the Boolean for enemy. However, because it's a child, it can then have its own additional variables. So it might be an enemy. So yes, it inherits enemy, but now let's also add the fact that it's got a skeletal mesh. I'm just gonna put SKM because I'm not spelling that out. Okay, great. So now we have a parent for enemies because they got the skeletal mesh, they've got NPC logic, they've got whether they're an enemy or not. So then we can then make different enemies from this parent. And guess what? They're gonna inherit enemy, SKM, everything in here. However, we can make other children from the highest parent, and they aren't at all related to this item. The only thing they're going to share is the fact that the parent has enemy in it, so these are also going to include enemy. Okay, great. So you kind of understand parent, children, more children, it keeps branching. But why? Why is this useful? Well, let's start putting names to these. Ignoring the fact I used a boolean and it says enemy, so just ignore that. Let's pretend we're making an inventory system. This is usable items, or like potions. Okay, so potions, I'll just put literally item, like usable. Okay, these are usable items, okay? Well, those are gonna be different than key items, right? Key items aren't usable. So they need different logic, they need different characteristics, but they still need to come from the parent. So we have usable items, we have key items, and maybe even equipable items, okay? So we got usable, key items, equipable items. You can see how these are different sets of logic, but we need the inventory to be able to accept all of them. So what do? What we do is we're gonna set up some logic that is going to look at the parent item and get everything it needs from that. Because remember, in Unreal, in our parent item, we have an item name and a thumbnail. Let's go back to Paint. That means that every single child is gonna have an item name and a thumbnail. So therefore, if we have an inventory of parent items, then that means they'll all have thumbnails and names. We can add descriptions, whatever we want. We just got to add more variables to the parent. But they can still be unique in their own way by being usable, key items, equipable, so on and so forth. I hope this is making sense. At least I hope you understand the concept so far. Even if you don't know how we're going to put it into practice, I don't care. I hope the concept makes sense. So this is our template. This is our parent item, okay? So for now, we're gonna say an item name, a thumbnail, and the implementation of being interactable is good enough as our template. So I'm actually gonna close the parent item. I'm gonna hit Control Space. And now we're gonna start creating different types of parents, as in different types of items. So let's start with something like a key. Let's go ahead and right click on our parent item. I'm going to go all the way to the top and you'll see we can create a child blueprint class. We're gonna click that. I'm gonna just type in BP underscore parent key, okay? Now, remember, this is technically under the parent item in the hierarchy. It's important to remember the hierarchy, okay? So we have a parent item that goes into a parent key. If you can't keep it straight, change your naming convention, add numbers, write it down, do whatever you need to do. But I will let you know if you forget and you get lost and you're like, oh, I forget which one's the highest of all of them. If you open the parent key, so remember, this is a child of parent item, look at the top right, parent class, BP parent item. So therefore, you know that this inherited everything from BP parent item. Now, you'll notice something, by the way. On the left-hand side, we have no variables, which is strange, right? Because it did inherit everything. I mean, you can see that it has the interaction request, which means it inherited the interface. So why aren't the variables there? Good freaking question. You have to turn that on for some reason. Up here at the top of the My Blueprint section, there's a gear. You want to show inherited variables, and all of a sudden, you now have your item name and thumbnail. Why you have to do that, I don't know. Why else would you make a child of a parent? I'm gonna rant here in a minute. It doesn't matter. Turn it on so you can see them. I'm gonna press Control-Shift-S again just to make sure everything is saved. Now we can start making a template for keys. Well, keys tend to have a static mesh because we need to be able to see them and pick them up. So I'm going to add a static mesh, and I'm going to call it SM underscore, or this is DM. I'm at SM underscore key. Control-Shift-S to save all and hit compile. Remember, I'm not setting specifics yet. I'm just adding more elements that are going to be for all keys now. We had the top, which was for all items. Now we're creating something that is for all keys. So we have SM key, or the static mesh. I'm gonna go to the variable. We're gonna create something called a key ID. And I'm going to make that an integer and hit compile and save. And honestly, for now, I think that's good. We might end up adding more to these later, but right now, I'm going to say that's good. We're going to go ahead and close the parent key. Let's open up with control space. And now, because it's no longer going to be a parent, I'm going to create a new folder. And I'm just going to call it keys. I'm going to right click on the BP parent key. We're going to create a child. And this is going to be BP underscore key 1 or whatever you want to name it. Control Shift S to save all. And we'll drag this into our keys. Now we're going to open up key 1. And now we're doing specifics. Okay. So now we're going to go into SM key. I do not have a key in this project, so I'm just going to use the chair, the SM chair. So there we go. Blah, 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 nanite, I'm aware. Hit Control Shift S and compile and check it out. Now we have a key that is a chair, and because it inherits everything, we also have the interface. So I'm going to go ahead and open that up. And now look. We can define what the chair does when we interact with it. Do you remember how we interact with it? Well, we hit F or whatever you set. We do a line trace. We see if we hit the chair in this case, because that's all there'll be. If we do, we check to see if it's got the BPI interaction implemented. We know it does. And then we send it a message called interact request, which will trigger this function. So for now, all I'm going to have it do is delete actor or destroy actor. I don't know why I typed in delete, which will be itself, and we will return a success, which honestly doesn't matter, but still. I'm gonna hit compile and save. And are you ready? Are you ready to see the start of your inventory system coming to life? I'm gonna go ahead and drag the key out on to the field. I'm gonna hit play. And then if I go over to the chair and I hit F, which will send a line forward, if we did it correctly, it will have inherited the interface, and in key 1, we defined that it needs to destroy itself. It's gone. That is the end of this episode. You might be thinking, wait, we didn't make an inventory. This was a huge first step with a ton of information. Digest it all. Try to understand parent to child stuff. We'll come back, we'll get further. But for now, please like, comment, and subscribe, and I have a new Patreon if you would like to support me, and I can bring you tutorials even more often of higher quality. You can support me down below, but I'll see you guys in the next video.